So this video, we're going to talk about that review packet for the first test. Okay, so keep in mind, this is not like an end all be all. If you know this, how to do these exact problems, you're 100% ready for the test. Not necessarily. These are more just kind of practice problems. It's kind of a broad overview of the types of things that you should be ready for. But make sure that you're also, looking at the worksheets. Make sure you're looking at the quizzes, and to prepare yourself for the test. Okay. But anyway, so let's talk about these. Okay, so one of the things we want to be able to do is, can you determine if fractions are equivalent or not, right? So remember, what equivalent means is they want them to be the same number or the same size, or this, in talking about fractions, especially comparison. Like, so for example, 3 compared to 5. Clearly 20 over 25, the tops, the bottoms are completely different numbers. But the point is, comparing 3 to 5, is that the same as comparing 20 to 25? Or keeping 3 out of 5, is that the same as keeping 20 out of 25? Okay. So there's a couple different ways you could do that. One way you could do that is you could get a common denominator, right? So that they're able to make the same comparison. So 5 and 25, you could get this to not only be 5, but then the same as the other one, 25, right? But you have to multiply the bottom by 5, and then 5 times 3 would be 15. So now 3 out of 5 is the same as 15 out of 25, but that's definitely not the same as 20 out of 25. So no, these are not the same comparison, right? So one way is to get a common denominator, okay? Now, it still is a common denominator per se, but another way you could think about that is just pick up a calculator and you do 3 divided by, if I turn it on, 3 divided by 5 is this decimal 0.6, and 20 divided by 25 is the decimal 0.8. Clearly not the same, so again, still no. Okay. Do realize that you are a common denominator. Remember, when you do that, when you do the division, you're just comparing to 1 now. Keeping 3 out of 5 is the same as keeping 0.6 out of 1. 20 out of 25 is the same as 0.8 out of 1. Okay. All right. So kind of the same thing here, like with B, you got a denominator of 112 and 208. Whew, those are big numbers. So finding a common denominator there, that's not 1, is going to be a little trickier. So in this case, this is one where you might want to actually, or let me just write these down. Use the calculator a little bit quicker. Okay, so 84 compared to 112, right? That's going to be 0.75, right? But now if I did 156 compared to 208, you're going to get 0.75. So it may not look like it, but they're totally different numbers. But keeping 84 out of 112 is indeed the same as keeping 156 out of 208, right? Because they have their same comparison out of 1. All right. Now, the last one here, hopefully you can just look at them and don't do any work and say, wait a minute, this is a negative number, this is a positive number, so clearly not the same. So no, but it's worth mentioning. Okay. You could get a common denominator here as well, like 30 and 60. It's pretty close because basically you could just double this one, right? If you double this one, that'll get you to 60, which means you'd have to double that. You could use a calculator. 26 times 2 would be double, would be 52, right? So wait a minute, they're the same. Oh, wait, no, they're not, because it's a negative, right? So they're close. They're not the equivalent. They're the exact opposite of each other, right? Again, you could also see that if you did 26 divided by 30, is that 0.86 repeating, but it's negative. And this would be that 0.86 repeating. So they're the exact opposite of each other, right? So they're not equivalent. They're opposites. Okay, same size, just different sign. All right, now what about 3 and 4? Notice both of these are kind of the same, right? Because both of these, it's telling you it takes so much, but I know everyone sees fractions and their brain just goes out the window, right? You got to train yourself to look at this and go, it takes, don't let that fool you, right? It takes a bunch of feet of lumber to create bookshelves, okay? Now with 3, they want to know how many bookshelves can be made with 20 feet of lumber, okay? So when you're doing these types of problems, you always want to think, what is it that I'm starting with? What is it what I want to end with? How do I make that happen? Right? So how many bookshelves? How many? So the question there is how many bookshelves? That's my end game, right? But what do I have is 20 feet of lumber. So think of it as kind of like you're starting. Oh, I skipped number 2. Whatever, we'll go back to that in a minute. You're starting with 20 feet of lumber. So what I'm starting with here is you have 20 feet of lumber. Okay. Where do I want to end up? I want to end up with how many bookshelves. I don't know how many bookshelves, right? But see, that's kind of the thought process. You want to think of it as what is it that I'm starting with? Lumber, and I want to turn it into bookshelves. Okay. All right. So how do I go from lumber to bookshelves? Well, they told me that if I had lumber, I can turn that into bookshelves. Or in other words, imagine every time I run across this amount of lumber, I can turn that into bookshelves. So kind of what you want to visualize, imagine you had that 20 feet of lumber, right? This is that 20 feet of lumber sitting there, and you're going to measure off, measure off, measure off, measure off, measure off. Then every time I run across this amount, you're going to turn this into bookshelves, turn this, 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 this. But what I'm measuring off here is feet, right? So each one of these is 7/4 feet, right? 7/4 feet, 7/4 feet, 7/4 feet, right? You're going to keep doing that, right? So you got all this lumber sitting there. Measure off 7/4 feet, another one, another one, another one, another one. You keep doing that. But each time, each one of these times you measure this off, you're going to turn it into 2 bookshelves. So 2 here, 2 here, 2 here, 2 here, 2 here, right? So I'm taking 20 feet of lumber, breaking it up into chunks of size 7/4. But what does that? Division does, right? So if you took 20 and you broke it into chunks of 7/4. Now I know everybody's like 7/4. I hate that. That's a decimal. Okay, fine. So 7/4 is really 1.75. So what you're doing is you're taking 20 and you're breaking up into groups of 1.75, right? So if you take 20 and divide by 1.75, that's going to give you this crazy number, 11.4285713. You don't need to write all these down, but just I'm going to make a point here in a minute. Okay. But what does this number mean? So what that means is I can take 20 and I can measure off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of these chunks and a little bit more. Okay. So there's going to be, I can measure off 11 chunks and a little bit more. Okay. But remember, each one of those chunks is going to turn into 2 bookshelves. So 2 here, 2 here, 2 here, 2 here. So you're going to take that same answer that we got, that 11.4285713, whatever, and you're going to multiply by 2. Okay. But the point is, look, it's already in my calculator. You don't need to write all that down. It's right there. So you can then multiply this by 2. And that's what's going to give you the 22.857, blah, 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 blah. It keeps going. Okay. So the bigger picture is 20 feet of lumber, breaking it up into chunks. That's division. Then take those chunks and you can multiply by 2 because each one of them is going to turn into 2 bookshelves. So this is, you're going to get this many bookshelves. Now, here's the thing. You got rounding is all about, you got to use your brain. Would rounding be appropriate here? Depends on the situation. In this case here, we're talking about bookshelves. Are you really going to make a part of a bookshelf? No, you're only going to make whole bookshelves. Okay. Now, mathematically speaking, yes, since this is an 8, you should go up to 23. But context, we're talking about bookshelves. You only have enough lumber to make 22 bookshelves and a blah. Okay. So you don't have enough to make it. So you can only make 22 shelves. Right? So again, I know that's weird because you should be rounding that up, but no, context is a problem. It's telling me I don't have enough. So you'd have to leave it there. And that's my end game. Okay. Another way that might help see that is, again, I know you guys don't believe me yet, but the wording would tell you what to do, right? So you can almost see it as kind of like one of those conversion problems. Because what are we starting with? We're talking about feet of lumber. And what am I trying to do? I'm trying to turn it into bookshelves. Well, if I want to get rid of feet of lumber, put it at the bottom, and I want to turn it into shelves, right? Okay, then you just fill in your numbers. They told me 20 feet of lumber. They told me 2 bookshelves is coming from 7/4 feet of lumber, right? So by writing the wordings down, they just fill in the numbers. 20 feet of lumber is what I'm starting with. They told me 2 bookshelves is coming from 7/4 feet. But look where everything is. See, look, you're literally, the 7/4 is at the bottom. That's telling you division. 2 is at the top. That's telling you multiplication, right? So it's telling you what you should do, which would turn into that 22.857 or 22 shelves. Shelves, right? Okay. What about 4 now? Okay. So it's kind of the same thing, but now how much lumber would you need if you wanted to make 10 bookshelves? So now we're starting with the shelves and we want to know how much lumber. Okay. So if you like that wording idea, if we're starting with 10 shelves, think of it as I want to convert those shelves into feet of lumber, right? But again, see how the shelves would cancel? There's your feet. Then you just fill in the numbers. So they told me 7/4 feet of lumber is the same as 2 bookshelves. But you see how the 7/4 is on the top? Multiply. The 2's at the bottom, divide, right? So you can do it in the calculator. I know nobody likes that 7/4. So you could do 10 times that, whatever it was. What was that? 1.25, right? No, 1.75, right? So the 10 times 1.75 would really be 17.5. Then you could take your 17.5 and then divide by 2, right? Because you're multiplying here, and then the 2 you would divide, right? So now you could take that 1.75 and divide by 2, right? Oh no, I forgot to multiply by 10. Like that doesn't make sense. Well, that's a good point to make because I took 1.75 and I divided by 2, and I ended up with this number. Okay, so does this number make sense? So if you had 10 bookshelves, would it make sense to have this much feet of lumber? No, that's less than a foot. Something's clearly wrong, right? And so, because I forgot to multiply by 10, right? So it's 10 times 1.75, right? Should be 17.5. And that's what I want to divide by the 2. All right, there we go. So that's going to give me 8.75. Now that makes more sense. So you need 8.75 feet of lumber. Okay. Now here's the thing though. Like, what about the rounding though? Well, like with the previous one, you're not going to make part of a shelf. Decimal doesn't make sense. But here, can you measure off part of a foot? Sure. You just measure off 8 whole feet and a little bit more, almost to the next one. So in this case, you don't need to round it. You could just leave it as 8.75 feet of lumber. Right. I don't know why, but I skipped 2. So let's go back and talk about these real quick. So with 2, you got 1/2 plus 2/3 times 9/4. Okay. So here, it's all about that order of operations, right? So if you guys remember, we'll talk a lot more about this later as well. But you guys remember that PEMDAS or the please excuse my dear Aunt Sally, whatever. But the main thing is you got to think the addition, subtraction, and multiplication, division, right? So these have to come first, and then you can do this, right? Remember the P is for parentheses, not a problem. Exponents, not a problem, right? So it's all about the multiplication, division, and addition, subtraction. Um, I know the addition and subtraction should come later, but I think it might be beneficial to think of this as this first, right? Because if you think of this first, you know what should come later, or you know what can wait, right? So what I mean by that is you see how there's a number plus a number times a number, right? So you got these 3 numbers here, right, with the 2 operators. Okay, so the real question is addition or multiplication. Well, the addition, I know I should do that later. So that's basically saying I got to add these together first. So let's go off to the side, and you would multiply these first. Right. So I know most people they like to do is multiply across. So 9 times 2 is 18. Then the bottom 3 times 4 is 12. Right. You could run with that, or you could reduce this, right? Because you reduce it by 6. 6 goes in 18 3 times, but 6 goes into 12 twice. Right. Or what you could have done instead of multiplying, you could have just gone back to here and looked if there's anything on the top and anything on the bottom have anything in common. Right. 2 goes into 4 twice, and 3 goes into 9 times 3 times. So you just have a 3 over 2, right? Without actually having to multiply. Either way you do it, it's up to you. But remember, we're trying to do a half, right? We're trying to do this half plus multiply these together. That turned out to be 3 halves. So it really should be a half from here plus the 3 halves that we got by adding those 2 together. Okay, now remember adding and subtracting, you need a common denominator, which is good because they already are, right? 1 out of 2 plus 3 out of, oh, look, the same. So if I have 1 of these plus 3 of those, and you really have 4 of those, which is just 2, right? All right. Then the second one, a little bit longer, but it was 18 tenths. We're trying to divide that by 12 fifths. You're trying to subtract 12 eighths. times 5/3. Okay. So again, doing this PEMDAS idea, yes, there's a division here, there's a subtraction here, and there's a multiplication here. What I think is helpful is if you identify that subtraction first, right? Because if you identify that subtraction first and you say, wait a minute, that better come last, but by recognizing that first, you've now separated it into two different problems, right? So you can do this problem, then you can come back and ultimately do the subtraction. Right? But that's kind of what's helpful is to recognize that first. Okay. So we got to go off to the side and we got to do 18/10 divided by 12/5. All right. So first off, how do you divide by a fraction? Remember, that's when you flip the second one. So this would be 18/10 times 5/12. Right. Now I know everybody likes to multiply across. You pick up a calculator, fine. So you have 18 times 5 on the top. It's this big number, 90, and then 90. Then in the bottom, you got 10 times 12, which is 120, right? You could work with that, or it might be easier to reduce this. Okay, so what do they have in common? Well, one thing to notice, they both end in a 0, so they both have a 10 in common right off the bat. So it's the same as 9/12. And you can hopefully see they have a 3 in common, right? 3 would go into 9 3 times, and 3 would go into 12 4 times. So this would be 3/4. Or really, what you maybe could say they had a 30 in common, right? 90 divided by 30 is 3, and 120 divided by 30 is 4. Right? Or, personally, what I would have done is gone back to here and just do the tops and bottoms have anything in common to begin with. Well, 5 goes into 10 twice. Then you could do, hey, 2 goes into 18 9 times. So look, there's your 9/12. And then you can see, oh, and 3 goes into there 3 times. And 3 goes into there 4 times. So you're just left with 3/4. Done. Right? So multiply first, then reduce, or cancel first. It's up to you. Okay. But now, all right, so that's just this part. Now we got to do this part, right? So we got to do this part here, which is the 12/8, and we're multiplying by 5/3. Right? Okay. So again, you can multiply the tops, right? So you're going to have 12 times 5. No. Right? 60. And the bottom, 8 times 3, you can check it out, but it's 24, right? Then you got to reduce this, or you could reduce it, I should say, right? So what do 60 and 24 have in common? You can play around with it. What they have, I don't know, maybe a 6 you could see. I don't think that's too deep because 6 times 10, right? So 6 would go in there 10 times, and 6 would go into 24 4 times. But then you could reduce by 2, right? 2 goes in there 5 times, 2 goes in there twice. But if you think 6 and 2, right, that's really 12, right? So you could have reduced by 12, right? 60 divided by 12, 24 divided by 12. You got to go with what you see. Or again, personally, go back to here. 3 goes into 12 4 times, and heck, 4 goes into 8 twice. Oh, no, look, 5/2. Done. Either way, it's up to you. All right, so the first part, this problem here, that was a 3/4. And then the second part here was the 5/2. But ultimately, we want to subtract those. All right, so now when we're subtracting, we need a common denominator, right? So if this is a 4, well, common denominator is we can get to 4, right? So 4 and 2 would both go into 4. So the first one we could leave, but this one you'd have to get it, right? So you'd have to multiply by 2, which means you'd have to multiply top by 2, which would now be 10. Now you can put your numerators together. So 3 minus 10 would be -7 of those 4. And there you go. Right. Well, actually, let me do that right here. All right. So also make sure that you can do the grid stuff here, plotting things. Make sure, especially with this one, maybe I should zoom in on this one. Make sure when you're doing these here, you got to pay attention to the grid, right? So normally each line is 1, 2, 3, 4, 5. Whoa, no, they're not, because look, it's labeled here, right? So you got to pay attention that these are really going by halves, right? So it's 0.5, 1, 1.5, 2, 2.5, 3. The same thing the other way, 0.5, 1, 1.5, 2. So you got to pay attention to that, right? So if you wanted to do -2.5, you're going to go full -2, but then 0.5. And then the 3, you're going to go all the way up to 1, 2, 3, right? So there's your point A. And remember the quadrant axes, remember it's up here to the right, up and to the right, there's 1, and then it goes counterclockwise. So 1, 2, 3, 4. And while we're at it, remember this is the x-axis horizontal, and the y-axis is the vertical one. So A is up here in quadrant 2. All right. So start at the origin again, 3.5. You're going to go to the right 3.5, and you're going to go down 1.5. All right. So that spot right there is B, which is in quadrant 4. All right. Now 4, 2, you're going to go right 4 up 2. Right. So there's C, which is in quadrant 1. 0, negative 0.5, meaning you do not go left or right, but you're going to go down 0.5. There's your D, which is not in a quadrant. It's on the y-axis. You can just write y. Who cares? And then -4, a full -4, and then go down -4.5. So it's right there at the bottom there. There's your E, which is in quadrant 3. And then the 2, 0. So meaning right 2, and then don't go up or down. There's your 0. There's your F, which is on the x-axis. Right? And there you go. Okay. What about 6? So here they want you to find the midpoint of the line segment connecting A and E from the previous problem. So here's A, here's E. You want the midpoint to that. So hold on, let me write this down. So the point A was the point -2.53, and the point E was -4, -4.5, right? So A and E. Okay, so here's my A, here's my E. Okay, so now remember what you're after is the midpoint. So the midpoint is we're trying to find the middle of it, or you can kind of visualize. Here's A, and then E was down here, right? Oh, sorry, you can't see what I'm pointing. So here's A, here's E. So if you imagine connecting those, we're looking for a point that's somewhere in this general area that's in the middle of those, okay? But remember how you do it, you're basically going to find the average or the mean of the x's and then the average of the y's, right? So how do you find the average or the mean? Well, you add them and divide by how many there are. So you take the -2.5 and you add the -4 and divide by, oh, there's 2 of them, right? So literally just add them, divide by 2. Use a calculator, fine. So -2.5, and then you're adding a -4, right? So that's really going to give you -6.5. And then divide that by 2 is going to give you -3.25, right? And then you do the same thing with the y coordinates. You average those by adding them. So 3 plus -4.5, and then divide by 2, right? Add them, divide by how many there are. There's 2 of them. Okay. So 3 plus I forgot what it was, 4.5. Right? So 3 plus -4.5 is -1.5. And then divide that by 2. So there's your -0.75. All right, so putting that together, when we average the x's, we got -3.25. And when you average the y's, we got -0.75. So that point is your midpoint, which you can check out on the grid here, right? So I want -3.25 for my x. So -3 is here. This would be -3.5. So 3.25 would be right in the middle, right? And then -0.75 would be, this is 0.5. This is all the way down to -1. And so 0.75 would be right in the middle right there. That's your number 6 midpoint. Which is good because if you look at that, it looks like it's smack dab in the middle between A and E. It's right in the middle there. Right on. All right. Moving on. All right. What about 7? So here you want the ratio. So stop right there. As soon as you think of ratio, you should be thinking some sort of comparison, fraction. Maybe it's a percentage. I don't know. But the ratio or the comparison of blue in a bag to the rest is 3 to 9. What percent of the M&Ms are blue? So percentage, again, they're looking for comparison, but now I want to, not just a 3 to 9 or 5 to 1, but they want you to actually do the division and get, a percentage, right? Okay, but the hard part here is you got to watch the wording, right? So when it says the ratio of blue M&Ms to the rest of the colors is 3 to 9, right? So it's all about that word 2. Whatever comes before the word 2, that's this number here. And then whatever comes after 2, that's here. So they're telling me the number of blue M&Ms is 3, and the rest of the colors is 9. Okay, so that's telling me you have 3 blue, you have 9 other colors. Okay, So what percent of the M&Ms are blue? Okay, so what they're looking for, they want a comparison, but in words, they want M&Ms that are blue compared to M&Ms that are, this is the hard part, what percent of the M&Ms are blue? So when they say of the M&Ms, they're talking about the whole bag. So what they're talking about is the blue ones compared to the total. Okay. Now, are there actual 3 blue M&Ms? Not necessarily, right? There could be more, right? But what this is saying is if you were to run across 3 of them, you better run across 9 other ones, right? If there were 6 of these, there would be 18 of these. You see I'm doing no doubling it? So it's the ratio or the comparison. So every time you run across 3 of these, you're running across 9 other colors, right? So if there were 3 blue M&Ms, what should be at the bottom? Everyone's, oh, it's 9. No, it's not 9, right? Think about that. Oh, I wish I had a blue color. I don't, but whatever. Oh, let's pretend this is blue. 1, 2, 3 blue M&Ms. If you had 3 blue, then you really have 1, 2, 3, 4, 5, 6, 7, 8, 9 other colors, right? So in this bag, if you run across 3 blue, you're going to run across 9 others, which means there's 3 blue compared to a total of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 M&Ms, right? So it's 3 to 12, right? But it's all about that wording. It's not blue to other colors, it's blue to the total, right? Okay, so then percentage-wise, I want 3 divided by 12. Well, first off, decimal-wise would be 0.25, but then percentage, you move it over, would be 25%, right? All right, but wait a minute. Bonus question. He wants to know what percent of the M&Ms are not blue. Well, if 25% are blue, then the rest are not blue. So you could just take 100% and subtract 25% to get 75% not blue. Or you could have looked at, hey, wait a minute, there's 9 not blue compared to 12 total. But in that case, 9 divided by 12, still 0.75 or 75%. Either way. All right. Okay. What about 8? Let's say you are traveling 45 miles per hour. Now stop before you read any further. What does this mean to you? Did you actually go 45 miles? No. Did you actually travel for an hour? No. You have no idea how far you actually went. You don't even know how long you were going for. All you know is if you went 45 miles, it would have taken you an hour. If you traveled for an hour, you would have went 45 miles. Or every time you go 45 miles, it's going to take you an hour. Every time I travel for an hour, it's going to take me, I'm going to go 45 miles, right? But it's comparison, it's the rate. It's just like up here. Were there actual 3 blue? Not necessarily, but if you were to run into 3, you'd have 9 of these. If you were to go 45 miles, it would take you an hour, right? Okay. But the point is, if you were to go 45 miles in an hour, how long would it take to go 71? So this is what this class is all about. Somebody you just got to use your brain and think about this. You just have a rough estimate. Well, if I were to go for a full hour, I would go 45 miles. So if I want to go 71, that's more than 45. But think about if you were to double this and go 2 hours, that would get me all the way up to 90, which is more than that. So you should be thinking it should be more than an hour, but not quite 2, right? So it should be a whole hour and then maybe a little bit more, which is why they want you to express answers in hours and whole minutes. So it's going to be a whole hour and then some minutes. That's the hard part. How many minutes, whatever that is. Okay. Well, I mean, basically you could just try stuff and do it. You're like, okay, I know I'm supposed to divide, and you say, okay, what is 45 divided by 71? Oops, that's not more than 1. That doesn't make sense. How about 71 divided by 45? Oh, that's more than 1. That's good, right? So that was 1 something. Okay, but again, what you could do is you could have the wording tell you what to do. So what did they tell me? There was 71 miles, right? But you can think of that whole conversion thing. I don't want miles. I want that to go away. I want hours, right? That's what they're looking for. How long? Well, they told me 45 miles in 1 hour. Oh, look, where's the 45? At the bottom. That's what's telling you should divide. So 71 miles in, going at 1 hour and 45 miles would be 1.5, technically 7 repeating hours. Okay, so there's your full hour, but then you have a part of an hour, but it wants it in terms of hours and minutes. Well, again, this is a full hour. This 0.57, I know some of you guys are already thinking it is 57 minutes. No, 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 don't do that, right? This is not 57 minutes because, again, this is only part of an hour. Think about that. It's 0.5, whatever, but it's 0.5. What does 0.5 mean? That means part of something. It means half. So this should be around a little bit more than half an hour. So it should be 30 something, right? So you could think of this as one full hour, sure, but that 0.57 hours, you're going to have to convert that to minutes. But remember, there's 60 minutes in an hour. So you would really have to take that 0.57, whatever, and multiply by 60, whatever. It's roughly going to be 34.6 repeating minutes, or we'll call it 35. So it should be 1 hour and 35 minutes, right? But the point there is that should kind of make sense because it's a full hour and this is 0.5, right? 57 minutes, that's almost a full hour. That wouldn't be half, but 35, there's your little bit more than half an hour, right? That should make more sense. Right now. Okay. All right, so what about 9 here, right? You got a store sells 3 different brands from a particular item. Determine which one is the best buy. So brand A, I can get spend $5, but I would get 14 ounces. This one it's less, but you're getting less. Even less, but you're getting less, right? So yeah, which one's the better buy? Well, you can play around with these, and it's probably worth doing it both ways to show you, right? So with brand A, you could do the 5 and compare it to 14. Then brand B, you could do the 425 and compare 12. And then brand C, you could do the 375 and compare 9. So all I'm doing there is I'm taking that 5 divided by 14, right? Just comparing it. Okay. All right. So you pick up a calculator. Let's do all these. So I got 5 divided by 14. So this is going to give you 0.357. Then do 4.25 divided by 12. It's going to give you 0.354, blah, blah, blah. 3.75 divided by 9. No, divided by 9. This is going to give you 0.416, blah, 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 blah. Okay. All right. So now what the heck does that mean? Well, this would be great if I could ask you guys what that means to you. Like, what do all these crazy numbers mean to you? This is where the wording would help. Because remember what we were talking about here. If you did it this way, you're talking about $5 compared to 14 ounces. This is dollars to ounces, dollars to ounces, dollars to ounces. So when you do this division, remember it's like over 1. So what you're talking about is dollars per ounce. This is dollars per 1 ounce, right? This is dollars per 1 ounce. So what this is saying is if you were to buy brand A and you would only get 1 ounce, it would cost you this much. If you were to get that same amount of brand B, 1 ounce, it would cost you, a little bit less per common ounce. This one is the most expensive because you're paying more for that common ounce. So B is the better buy. But also it's worth mentioning, what if you did it the other way? What if you did 14 divided by 5 and you did 12 divided by 4.25? Over here, you did 9 divided by 3.75. Okay. So if we did it this way, 14 divided by 5 turns out to be 2.8, right? 12 divided by 4.25 turns out to be 2.8. We'll call it 2, blah, 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 whatever. Then 9 divided by 3.75 turns out to be 2.4. Okay. Now, which one's the better buy? Well, you got to think about what you're doing. Remember, it's all about the wording, the units. Remember, 14 ounces per $5, 12 ounces per $4.25, ounces to dollars. So what this is saying is 2.8 ounces per $1. This is 2.82 ounces per $1, right? This is 2.4 ounces per $1. So what this is saying is if you were to buy A and you only spent $1, you would get this much. With B, if you spent $1, you would get more. And with C, if you were to spend $1, you would get the least amount. So B is still the better option because you're getting more for that common dollar. right? So the wording kind of tells you, like, see here, you're spending the least for the common ounce. Here, you're getting more bang for your common buck, right? You're getting more stuff for that dollar. But either way, B is the better option, right? All right. So what about 10? So you got this. Students take a test yielding the following results, fill in the chart, then answer the questions, blah, blah, blah. Okay, so first thing you got to do is fill in the chart. Well, so what are we talking about? These are people that studied. These are people that did not study. Going across, these are earned a C or better on the test, earned below a C. Well, it's kind of the same thing. 12 plus blah, it gives you 19. Well, you could subtract these. 19 minus 12 would be 7. Right? You could do the same thing here. 12 plus blah is 15. So if you subtract, that had to have been 3. You could add down here is 17. You could add across here is 13, right? Then you should add down here. And you should also check adding this way. I mean, if you need a calculator, whatever. So we got 19 plus 13. Sure enough, it's 32. But as a check, if you went across 15 plus 17, it's also 32. Okay. So I would highly recommend that. Make sure you do add both ways to check to make sure. Okay. So now we got the chart filled out. Now, what percent of the class studied? Okay. So the key here is of the class studied, right? So the of the class is telling you your denominator. So when you go to do this, this is the bottom, the of part, right? Think of it as like is over of, right? So the of part is the whole class, the total. And of that class, we want the ones that studied, right? So the big group here of the class is 32 total people. Of those 32 people, how many people studied? 15 total, right? It doesn't mention anything about getting a C or better. I don't care about that. All I care about is the people that studied compared to the total. All right. So 15 compared to 32. There's the, well, 0.46875. Okay, now hold on. It does say here round to the nearest tenth. Okay, but it wants a percentage. So first thing off, when you pick up a calculator, this is the decimal. To get to a percentage, you got to move it over 3 slots. So this is really saying 46.875%. But if it says round to the nearest tenth, that's this slot, right? Remember, these are holes. That very slot, this is the 10th. So since this is a 7, you would round this up. So ideally, you would say 46.9%, right? So you got to get the decimal first, get it in a percentage by moving over 2 slots, then decide what to round it to, right? If it doesn't say, you can go to a whole number, sure, but it did say, you better do it. Right? Okay. So now what about B? What percent of those that studied earned a C or better? But again, it's all about that of those that studied, right? So of those that studied, we're only talking about this group, right? So my of group here are the ones that studied. Looking at the ones that studied, we also want, now a smaller group within that is the ones who got a C or better. So we're only looking to study. Within that study group, we want C or better, right? Okay. So the ones that studies are 15. In that 15, how many got a C or better? 12, right? So 15 total people studied. 12 of them got a C or better. All right. So we got 12 divided by 15. There's your 0.8 or 80%. When you move it over 2 slots, right? You can move it over 1, 2. So you got to tack on that 0. So it's really 80%. Mm-hmm. All right. And what about C here? All right. What percentage of the class did not pass? But again, of the class, oh, that's everybody, did not pass, right? So you're looking at the total here at the bottom, and you basically, below C, right? Or let's go C below. I'm just lazy. So the total group here again is 32. Of those 32 did not pass, basically earned below a C would have been 13. Right? So 13 divided by 32, there's your 0.040625. Okay. Now, Also, here you got to watch it. Like with A, it told me what to round to. C did not. Okay, so it's kind of up to you what you want to round to. But when in doubt, just do a whole percentage, right? Because if you move this over, and then you can look at that, you can go up. So 41% would be good, right? If you wanted to do 40.6, that's fine. If you wanted to do 40.63, that's fine. But a whole number is good, right? If they don't tell you. And then what about D here? What is the simplified ratio of students that did not pass and studied to those that passed and studied? So first off, it wants a simplified ratio, right? So it's kind of the same thing. We want a fraction, but instead of picking up a calculator and division, you just want to simplify it, basically. But it's a ratio of the students that, but again, the word, once you hear that word ratio, you want to be thinking two, that's your division. So you're comparing students that studied and did not pass compared to those that passed and studied, right? So students that did not pass who's here, and studied, so did not pass and studied, there's your 3, right? Compared to those that passed, so that's up here, and studied was 12, right? So in other words, you're talking about 3 compared to 12, which instead of picking up a calculator, you reduce it by 3 would be 1 to 4. That's what they want. They don't want you to divide it and get a percentage because it says simplified ratio. Or basically what this is saying is, look at those that passed and studied compared to those that did not, this number is 4 times bigger than this one, right? 1/4. So what that's saying is basically you're 4 times more likely to pass if you study. So you should study, right? That's what that's saying. Okay. What about these plotting things with crazy decimals? Okay. So the first one here, 4.2, right? The whole is 4, so that's clearly over here, but then it's 0.2. Now, wait a minute. Before you start doing this, you got to make sure. See, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 little tick marks, which means there's 10 slots. So each one is a tenth, or 4, 4.1, 4.2, 4.3, 4.4, 4.5, blah, blah, blah. So 4.2 would indeed be right there. There's your 4.2. Negative 18 fifths. Oh, God, everybody panics. Yes, it's crazy fraction, sure. But maybe think of it as negative 18 divided by 5. So this is really negative 3.6. Okay, so negative 3 whole, and then 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So there's negative 3.6. And then negative 4.6. Okay, so there's negative 4, then 1, 2, 3, 4, 5, 6. So right in there. Oops. Is negative 4.6. All right, then the last one, 11 thirds. Again, you don't like fractions, great. 11 thirds. Oh, this one's a little bit tricky, though, because you see how it's 3.6, but it keeps going. Okay, so you got to make sure that you pay attention to this one, the aspect of this is 3.1, 2, 3, 4, 5, 6. So right in there, that dot right there, that slot is 3.6, right? That next slot right there would be 3.7. So 3.6666 repeating is more than 3.6, but it's not quite 3.67. So it's got to be in between there, right? And that's the whole point. It's got to be more than this one, but less than that other line. So it's in the middle, okay? Make sure that you have that in the middle. Right on. Okay. What about 12 here? All right. So Joanna recorded the following times running 1 mile, right? So blah, blah, blah. So first off, it wants to know the mean. Oh, okay. Mean's pretty easy. Hopefully just add them and divide by how many there are. So let me just write these down. Okay. So her mean, her times were 6.2 minutes, 7.3 minutes, 5.8 minutes, 6.6 minutes. Okay. So we can add them all up, right? So we have calculator 6.2 plus the 7.3 plus 5.8 plus 6.6, right? So that's going to give you 25.9. All right, so that's what them all added up, and there are 1, 2, 3, 4 different numbers here. So if you take that adding and divide by 4, it's going to give you 6.475, right? Okay. So there's her mean time. Okay, but wait a minute. Now for part B, it wants you to convert the mean time to minutes and seconds. So again, what you just did, this was just minutes. Okay, so this is 6.475 minutes. Okay, but the whole part here, this is 6 minutes. This, we want the number of seconds here, but this is a decimal. Again, this is not 47 seconds. Don't do that, right? Because that's that same thing. This is part of a minute. So you're going to have to convert that, right? Basically, you got to multiply by 60, right? Because there's 60 seconds, right? So if you take that 0.475, the decimal part, and multiply by 60, you're really talking about 28 and a half seconds. So it's really 6 minutes and 28.5 seconds. Right, which again should kind of make sense because you think of 0.4, blah, 0.4 blah is a shade under 0.5, right? So that's a shade under half. Half of a minute is 30 seconds, so a little bit under 30 seconds should make sense, right? Okay. Now we see here, it wants to know how long in minutes and seconds should her next run be so that her new mean is 6 minutes and 30 seconds. Okay. Well, wait a minute. I can't work with minutes and seconds. So first off, you have to realize 30 seconds, that's half of a minute. So if you put this together backwards, this would really be 6.5 minutes, right? So what that's saying is, think of it as her first time was 6.2. The next one was 7.3, right? The next one was 5.8, and the next one was 6.6. Okay. But we want to know how long should the next one after this be, right? So that means there's some other number here that I don't know. I'm going to add. But when I add these all up and divide by 1, 2, 3, 4, 5 of them now, you want your average to be 6.5, right? So if I add up all 5 of these and divide by 5, I need it to be 6.5, okay? And that's the goal. What is that missing time here, okay? All right, so how do I do that? Well, it's kind of similar back to here, right? These two numbers, add to 19. Well, how did you figure that out? You did the opposite. So if you don't know what added to get to 19, you can subtract them. You do the opposite. It's kind of the same thing here. I don't know what divided by 5 gives me 6.5. So if I don't know what divided by 5 gives me 6.5, you can multiply, okay? So that means all these numbers up here, if you did 5 times, I probably should write it, but I'm doing the 5 times 6.5 is 32.5. So that means 6.2 plus 7.3 plus 5.8 plus 6.6 plus this mystery number better add up to 32.5, right? But if you add these together, I already know what those are, right? That before, that was the 25.9. So that means 25.9 plus this next time, I don't know, should add to 32.5. But again, it's that same idea. I don't know what number I'm adding to get to here. So you can figure it out by subtracting, right? So 32.5 minus 25.9. Right? So if you take that 32.5 and you subtract 25.9, you're going to get 6.6, right? But again, that's in minutes, right? So what they wanted was in minutes and seconds. So how long in minutes and seconds? So again, this is 6 whole minutes, and this is part of a minute. Again, that's not 6 seconds or 60 seconds. That's a little bit more than half a minute. So you'd have to take that partial, that 0.6, and again, multiply by 60 because there's 60 seconds, right? So it's really going to be 36 seconds. So if she ran for 6 minutes and 36 seconds, on the next run, that would give her an average of 6 minutes and 30 seconds overall. Right on.